Welcome to David Alexander Maths Tuition. This is chapter 14H on logarithms and non-linear data. The next part of the question says the straight line of log A against B is plotted. Okay, so on the y-axis we have log A and on the x-axis we have B. So the gradient is something we need to work out and the value of the y-intercept. So we know that y equals mx plus c. M is the gradient, c is the y-intercept. Now y is the log of A. So the log of A equals m lots of B plus c. Now we know from this equation that the log of A is log 3 plus B log 8. So if I write that log A is log 3 plus B log 8, then one of these things must be the y-intercept and one of them must be the gradient. Now the gradient is the m, which is the coefficient of b. So this is the b log 8 is the the only thing with a b in it. So therefore b log 8 means log 8 lots of b. So therefore the gradient is log 8. And therefore the y-intercept, RC, is log 3. So the value of the gradient, well, I suppose you could write it just log 8, but what is the log of 8? That is log 10 of 8. So therefore the gradient is 0.903 and the y-intercept is log 10 of 3, which is 0.477. Okay, so here's another example similar to what we've done before. So A and B satisfy this formula. What we need to do, because we want to put it in log form, is take logs of both sides. So we can say that the log of A is log 5b cubed. Now 5b cubed means 5 times b cubed. So I can write that as 2 logs. So that's the log of 5 plus the log of b cubed. This power here can come down to the front. So that is log 5 plus 3 log b. There we go. So the straight line of log A against log B is plotted. So log A is the y-axis and log B is the x-axis. So we want this, we know that if we're trying to work out the gradient and the value of the y-intercept, let's think about y equals mx plus c, where m is the gradient, c is the y-intercept. But y is not y is log A. And x is not x, x is log b, so it's m log b plus c. Okay, so we know that the log of A is log 5 plus 3 log b, so therefore the log of A is 3 log b plus log 5, so therefore m equals 3 and c is log 5. So c, let's just work out what log 5 is. So log 10 of 5, and we can work out that c is 0.699 to 3 decimal places. Okay, here's a question that resembles quite a few that are in the book here. So it's asking us to copy and complete this table of values of x and log y, giving answers to 2 decimal places. So we just need to take the log of these numbers. So log 162, so log 10 of 162 is 2.210. Log 10 of 4374 is 3.641. And the log 10 of 39366 is 4.595. So that's the first part of the question done. We've successfully filled in that table. Okay, so we've done the easy part of the question, now on to the harder part. So we want to plot a graph of log y against x. So log y is the y-axis and x is the x-axis, of course, and we can plot these points. And, well, what can we do from here? So let's look at the original equation. We want to work out what a and b are. Well, if y equals ab to the x, we can take logs of both sides. So log y equals log ab to the x. So that is log y, and log a b to the x is log a plus log b to the power of x, which is the same as x log b. Now I've got log y against x, So log y is log y. We know the equation of a line is y equals mx plus c. So what is a gradient? What is the y-intercept? Well, mx, the number in front of the x, is the gradient. So therefore our gradient is the log of b. And log a is the y-intercept. So the y-intercept is the log of a. So I can get the y-intercept by looking at my graph. And if log a equals this, then I can work out what a is. I can get the gradient, and if I can get the gradient, then that is the log of b. And if log b equals some number, then I can work out what b is. Now, what I'm going to do, going to be a little bit sneaky. Rather than using my graph to work out the gradient and the y-intercept, just to check I've got it right, I'm going to type these values here into my calculator. So what we're going to do is we are going to menu setup 6, statistics mode. So you'd have 4 options there. You want the second option, y equals a plus bx. We're going to type in those x values, so 2 equals 3 equals 4 equals 7 equals 9 equals. Then go to the right and then type in the corresponding y values. And once we've done that, we're going to hit equals. And we're going to press the option button. So that's top left underneath the shift button. And then we're going to do 4, which is the regression calculator. Now this is something you'll be using a lot when you do stats. So we can see that it says y equals a plus bx. So it's the b that is the gradient and it's the a that is the y-intercept. So here we are getting the gradient is 0.47735 and the gradient is log b. So what we can therefore say is that log of b is 0.47735. So therefore b is going to be 10 to the power of 0.47735. On the calculator it says that a is 0.301235. So that is the y-intercept. So therefore the log of a is 0.301235. And well, again, these are the values that we should be getting off our graph. Probably a bit dodgy if you get it quite as precise as that, but just take something that seems vaguely sensible, I suppose. So therefore a is 10 to the power of 0.301235. So what is the value of b? So we just need to grab our calculator for this final calculation. Okay, so we just need to type in 10 to the power of 0.47735, and so b is 3.0015, probably makes more sense just to call it 3, and a, which is 10 to the power of 0.301235, and that is a is 2. So y equals a b to the x, well, a is 2, b is 3, so the original equation would have been y equals 2 lots of 3 to the power of x. And we can just double check that using some of these values. If I do 3 to the power of 2, 3 squared is 9. If I multiply that by 2, I get 18. Oh, that's kind of convenient, isn't it? 3 cubed, 3 times 3 times 3 is 27. Double that, I'm getting 54. Okay, so there we go. We know we've got it right. So quite a tricky one, but yeah, you can definitely use your calculator to sort of fudge it along, really.